Hi, this is Wei Liu, Marketing Manager from Texas Instruments. Today we'll talk about isolated bias supply with flybuck solution. Here join me in the discussion we have Anoop, Field Applications Engineer from Würth Electronics Midcom, and Xiang, System Applications from Texas Instruments. There are a lot of isolated bias supplies in industrial applications, such as factory automation, PLC I/O module, and smart meters. So isolation is required to meet the safety standard, to prevent ground noise interference, or to generate a negative bias supply. So in those applications, they require a very compact, cost-effective, and easy-to-design power solutions. Traditionally, we have flyback solution widely used. So Xiang, maybe you can tell us, is there any other solutions available? If so, how does it compare to a flyback?
Yes, we have the flybuck solution. The flybuck topology is developed from the buck topology. It's very similar to synchronous buck, but we add a couple windings on the inductor to make it a transformer and create a flyback-like secondary outputs. So in this way, we can create multiple secondary isolated outputs to the flybuck. And it's a simple to design and easy to use and compact solution for isolation power supplies. And we create a case comparison between flybuck and flyback. So these two circuits, as you can see, the flybuck is a 4-output isolated power supply, and the flyback it's a 2-output isolated supply. The flybuck, the schematic is simpler than the flyback, and it uses less external components. And the solution size is even smaller than the flyback. And the flybuck 4-output solution can give good regulation within plus minus 5% regulation and good efficiency. So it's a good solution for the low bias power kind of application.
So are there any special design considerations for a flybuck?
Yes. Actually, the flybuck is easy to design because the primary side regulated as a normal buck. And the secondary output is just the primary side output times the transformer turns ratio. But not all bucks can be used in the flybuck. As you can see, the current waveforms, sometimes if we are putting heavy loads on the secondary side, the primary side current can go negative. That means you can only use synchronous buck for the flybuck configuration. And also, since it's a buck configuration, you have to have your primary side output lower than your minimum V-in. And a good design, we can keep a 20 to 40% duty cycle. That's a good balance duty cycle.
Xiang, I saw you have shown a pretty cool quad output reference design. Can you tell us a little bit more detail about the design?
Yes, we have this core output flybuck design. Using the LM5017 buck regulator, we create 4 output, the plus minus 15 volts and plus minus 5 volts. The plus minus 15 volts has 50 milliamp current capability, and the plus minus 5 volts has 100 milliamp current capability. Also, this board design is compatible with other configurations. Let's look at this board. So by changing the transformer, we can reconfigure the core output to a dual output. This one has plus minus 5 volts output. Also, there's another configuration. Let's look at the other board. This one, by changing the transformer, also a few components, we can reconfigure the board to a plus minus 15 volts version.
So that sounds pretty cool. So what are the other offerings in this flybuck family?
Yes, so the LM5017, it's a 100 volt YV-in synchronous buck converter using constant on-time control. And we have other options for a lower V-in version, like LM25017, and also other lower current versions, like 5018 and 1519. And this constant on-time control is perfect for the flybuck topology because it doesn't need any compensation network, and it has minimum required external components, and it's easier to use and design.
So Anoop, seems like a transformer is a pretty important piece in this flybuck solution, yes, right? So can you tell us a little bit more about the difference between a flybuck and a flyback transformer?
Sure. In a flybuck converter, the primary winding is a regulated output winding. This is very analogous to a secondary output winding in a flyback transformer. The design of both these windings are very similar. Also, we have the other isolated secondary windings in the flybuck topology, and their design is done based on the turns ratio calculations that is done in a standard transformer. The ratio of the output turns to the input turns equals the ratio of V out to Vin. V out is the desired output voltage, and Vin is the regulated primary windings voltage. The calculation of inductance is of great importance here, and this is done keeping the ripple current in mind. There are other factors that come into play, like the switching frequency, the input voltage, and the output voltage on the primary winding. Last but not the least, as Xiang mentioned, there are multiple secondary outputs over here. For all those unregulated secondary outputs, while computing the output voltage, the diode drop has to be kept in mind.
What are the design guidance for the flybuck transformers?
The most important point to keep in mind is the current handling capabilities. We have the rated current or the RMS current that affects the heating issues, potential heating issues in the windings, and then we have the saturation current that could affect the saturation factor of a core. And the calculation of both these currents in a flybuck transformer is pretty complex. So designers have to keep both these currents in mind while designing a flybuck transformer. Also, coupling is of great importance here. The cross-regulation between the different windings helps in reducing the leakage inductance. So we have to make sure that all the windings are coupled really well.
Okay, thanks. So customers have different requirements, right? So what are the different transformers you have designed, and how customers can order those transformers?
So we have designed 3 transformers for this particular evaluation board. We have a quad output transformer, plus or minus 5 volts, plus or minus 15 volts. We have a dual output transformer, which is plus or minus 15 volts, and another dual output transformer, which is plus or minus 5 volts. All these transformers are released and they are sold as standard components on websites like DigiKey and Mouser, and customers can always visit our website www.v-online.com/midcom to get samples.
Okay. So just to give us a little bit more idea about the advantages of Würth Electronics Midcom.
Sure. The number one advantage of all these transformers is that we have a fine balance between the interwinding capacitance and the leakage inductance. Overall, this improves the efficiency of the transformer. Also, the transformers are designed to operate in a temperature range ranging from -40 to a positive 125 degrees Celsius. They also have a higher dielectric rating of 1500 volts AC for a minute, and this increases the reliability factor. The automation is kept in mind while designing these transformers. As these are automated, it reduces the element of human error and also helps with lower costing. Last but not the least, while designing all these 3 transformers, we have kept the pinout very consistent. For example, the pinout of all the dual output transformers are exactly the same. And this just helps the customer in terms of swapping transformers in and out. They have more flexibility depending on their power levels, their application, and their requirements.
Okay. Seems very flexible. So I think we're curious to see how this board works. Xiang, I saw you already have a board connected. So what are you going to show us today?
Yeah, basically I will just power this up and show you the regulation results of the core output flybuck board. As you can see, we have the core output boards here. So let me power this up. And this multimeter showing the V-in, it's at around 24 volts. And this is the multimeter showing the 5 volts output. This one shows the 15 volts output. This one showing the -5 volts output. and this one showing the negative 15 volts output. As you can see, all the 4 outputs is well regulated. And also, we connected to the electronic load. Let me turn this on. So this channel is connected to the 5 volts output. I will set the load at 100 milliamp and turn it on. And the other channel is connected to the 15 volts output. I will set the current at 50 milliamp and turn it on. So now both loads is on, and all 4 outputs are still stay in the stable outputs. And let me change the V in. So from 24 volts, we can go all the way down to 17 volts. As you can see, the output is still stable and well regulated. And we can also increase the V in up to 32 volts. And you can see all 4 outputs, by changing the V in and the load, they are stay within the plus minus 5% regulation region. So that's the demo.
Okay, sounds great. So I think in this session we talk about the flybuck, and thanks Anoop and Xiang give us a very good introduction and the design guidance, and also demo the board. So in this session, we learned flybuck solution is a great candidate to replace flyback in industrial applications for isolated bias supply. It has a great flexibility and also is a very compact, very cost effective, and easy to design. So to order sample and find more information, please access to the web links on the screen. Thank you.